Yeah. Good morning, children.
Good morning, sir.
Good morning, sir.
Good morning, Chakrika. Good morning, Amulya. So now, as in a part of our learning, today we are going to learn the most important topic called. I don't want to reveal the topic name. I just wanted to make you should reveal the topic name. See, during the daytime, we'll get the light from. During the daytime, my question is, we will get the sunlight from. I give a hint also.
Sun.
Sun. Good. What happens during the night time?
Bulb. Electric bulb.
Bulb. Electric bulb. So where do you get that energy? What kind of energy it is?
Electric
Electric
current.
energy.
Electrical. Electrical.
Yeah. As children, today we are going to learn about electric current. So this electric current is of two types. Maybe in your ninth standard already studied. One is static electricity. One is current electricity. The charges which are at rest is called. The charges which are at rest is called static electricity. The charges which are in motion is called
Current electric.
current electricity. So, in brief, I tell you the study of charges which are in motion and their various effects. The study of charges which are in motion and their various effects is called electric current. So, today we are going to learn about what?
Electric current.
Electric current. Very good, better. So, are you able to see the screen?
Yes, sir.
So, our chapter title is what? Electricity.
Electricity.
City.
Okay. What I said, electricity means what is in motion?
Charges.
Charges are in motion. Observe if the spelling of the electricity is correct here. Is the spelling is correct? No, no.
No.
Yeah, you need to observe sometimes these things. Yeah. What are the contents? I expect Chakrika. Can you read what we are going to learn?
What is charge? Properties of charge. Methods of charging. What is electricity? Electric current. Electric field. Electric potential and potential difference. Ohm's law. Resistance. Electric circuit and components. Current and voltage measurements. Combination of resistance. Series versus parallel.
Among all, today I think we are going to learn about till Ohm's law. Okay, in the first part, what is a charge, properties of charge, methods of charging, what is meant by electricity, electric current, electric field, electric potential and potential difference, till Ohm's law we study. And the next episode we'll learn about resistance, electric circuit and components, current and voltage measurements, combination of resistances, series versus parallel, and more heating effects of electric current also there. But here they're not mentioned. The next thing we'll cover that. So do you think what is meant by a charge? Do you have an idea? At least types of charges. Do you have an idea about charges beta? Say yes or no. If you don't know, I'll say you. Don't know? Okay. Charge is nothing but charge is a type of behavior of a property which governs in presence of electric field as well as in presence of magnetic field. Understand better? Charge is nothing but what? A type of behavior of a charged body. So what is telling they have? Charge is an inherent property of matter that feels at the force of attraction or repulsion. So can anybody repeat what is the definition of charge? Lakshita,
Yes, sir.
can you repeat man?
Charge is an inherent property of matter that feels force of attraction or repulsion due to excess or deficiency of electrons.
Superb. So there are two types of charges. One is positive charge, another one is
Negative
negative
charge.
charge. And positive charge happens due to the deficiency of electrons, means by losing the electrons, and negative charge occurs due to the excess of electrons. And in both, the charge is nothing but because of electrons. What is the SI unit of charge?
Coulomb.
Coulombs.
Coulomb. And it can be detected, or a charge presence can be known by using an instrument called electroscope. So there is a beautiful example of gold leaf electroscope is also there, beta. There's a beautiful example of gold leaf electroscope. Yeah. How a body becomes charged. So these are the four methods. How can we make a body as charged? First one, anybody? I expect Amulya, will you?
Electrons rubbed onto
Ebonite rod. When ebonite and fur rod is rubbed together, ebonite is positively charged and fur is negatively charged because ebonite is losing and the fur is gaining. In next case, with a pith ball is attracted to a negatively charged body, means like a pencil or a graphite. And in next case, a glass rod with silk cloth. Glass rod loses electrons and acquires positive charge, and silk cloth gains. So again, these are also attraction. So what do you understand here? Like charges repel, unlike charges
Attract.
attract each other. The next, so this is a gold leaf electroscope, how it will be. So it consisting of a metal disc, a car, and a copper wire. At the end of the copper wire, we have aluminum foils. So nearby a metal disc, if you place any rod which is charged body, this gold leaf electroscope leaves are moves away. As they are moving away, that indicates the presence of electricity. So what are the properties of charge? Simple. The total charge always remains constant, and like charges attract, you know that already. Unlike charges repel each other.
Repel.
Is this correct? They wantonly given wrong statement. Like charges repel, unlike charges
Unlike that, attract.
attract. Like charges repel, unlike charges attract. And charges are additive. We need to always to take charges are always additive, means you take some 6 coulombs, 5 coulombs are there. Then total charge 6 plus 5, 6 plus 5,
11.
11.
11 coulombs. And charge is always quantized beta. The meaning of quantized means they given the formula as Q is equal to N into E. Where N represents number of electrons, E represents charge of electron. What is the charge of electron? 1.6 into 10 power minus 19 coulombs. How much the charge of electron? 1.6 into
1.6 into 10 power minus 19 coulombs.
super. So the methods of charging, it's not required, but just for an idea. We can charge a body by using conduction, by using induction. What is conduction? I expect Chakrika, can you read?
When an uncharged body is brought into contact, touched with an charged body, then the charge or electrons are transferred from the charged body to the uncharged body. This charges the uncharged body.
It's simple. When two bodies are there, which is one right side is charged, left side is uncharged. When this one brought closer to the right hand, obviously my left hand also will be charged. That's by conduction. Conduction means by physical contact. Induction. Induction means there is no physical contact. Similarly, like previous, charge will be induced, but without any physical contact. Means my right hand will be here, my left hand will be here, but still the left hand will be charged. So that is called induction. So
Induction.
this can be witnessed by when you keep your hand in front of your TV screen. Have you
Yes,
find a
sir.
goosebumps of your hair? Yes. So that is charged by induction. So now comes to know what is meant by an electricity. An electricity is nothing but it's a form of energy, and it can also be defined as flow of electrons in a circuit. So now you see in wide variety the electricity used either heating effects or cooling effects or motion of a power for a communication purpose and for light purpose. Of course, now you're learning an online classes comes under. Out of four, your online classes using laptop or using your phone comes under
Communication.
communication. So you're in this pandemic situation also you're capable to listen the classes because of the communication. Okay, the flow of electrons is nothing but current electricity. So now the important fact or important definition is called electric current. What is mean by an electric current? So what does electric current means? The rate of flow of charge. When I said rate beta, so many times I specified to you a physical quantity. If we divide with respect to time, that is called rate. The rate of flow of charge, nothing but I is equal to Q by T. I is equal to Q by T, where Q is already we know. Q can be written as NE by T. N stands for number of electrons. E stands for charge of each electron. What is the charge of electron? Do you remember?
1.6.
1.67 into 10 power minus 19 coulombs.
Coulombs. Very good, beta. Now you see, and immediately you can say electric current is a dash quantity.
Scalar.
Sir.
Scalar
Scalar
quantity.
quantity.
Coulomb per second is also called
Ampere.
Ampere.
ampere and denoted with capital A. Dash is used to measure electric current.
Ammeter.
Meter.
Ammeter. How to take its direction? In the direction of flow or opposite direction of flow of electrons?
Opposite to the
Opposite
flow
direction.
of electrons.
Yeah, beta. Opposite to the flow of current means that is conventional. That is conventional. That conditionally it will flow from in the direction of flow of electrons, but we are taking opposite, so you can call it as conventional. For our convenience, this direction has been specified or taken. So it flows as a result for the potential difference across the ends of a conductor. So quickly, what is the formula of I?
Q by T.
Q by T. Coulomb per second is called
Ampere.
ampere. Dash is used to measure electric current,
Ammeter.
Meter.
ammeter. And how to take the direction of current?
Opposite.
Opposite the flow of electron.
Opposite the flow of current. I is equal to NE by T. What is E and what is its value?
Charge of each
Charge of
electron.
electron.
1.6 into 10 power minus 9 coulomb.
Super beta. Very good, Nana. The next, what is meant by an electric field?
Field.
So just for information purpose, it are giving for you. In static electricity, 9th standard you studied. The force experienced by unit positive charge, F by Q. Force per unit charge is called electric field intensity and its unit is Newton per Coulomb. Newton per Coulomb. And remember, electric current is a scalar quantity, but electric field intensity is a vector quantity. Is that okay, beta? Newton per Coulomb, just for information. And now the next major important one is electric potential. What is it? Electric
Potential.
potential and
Potential.
potential difference. So the simple definition, it's an amount of work done in bringing a unit positive charge from infinity to a given point in an electric field. Means it is somewhere we are bringing it to some point, a specified point. For that you have to do some work. We are doing work on whom, beta? Charge. We are doing work on charge. That's what W by Q is a formula for potential and denoted with V. And what kind of quantity it is also? scalar quantity. And unit is joule per coulomb. Joule per coulomb is also called
Volt.
Volts.
volt. Yeah. Now can you say what is electric potential symbol?
V.
V. If I was given V is equal to W by Q, what is W? What is W? Q for? At least Q for? What happened? Q for? Q for charge and W for work. Can you repeat now? What is W? Yeah, I'm not getting your voice better. What is W? Hello? Hello?
Yes, sir.
What is W? Work. Q for charge.
Work.
Repeat it. Work by charge. The work done in bringing a unit positive charge from infinity to a given point is called electric potential. And electric potential is a scalar quantity. Electric potential is a scalar quantity. Understanding everyone?
Yes, sir.
Done, beta. And its units are joule per coulomb. Joule per coulomb is also called
Volts.
volt. So what do you mean by potential difference? You may ask means initially we brought from infinity to a given point, but now from one point to the other point. Down there was given C. If you take from infinity to A, that is potential. But from point A to point B, that's called potential difference. This is also scalar quantity. Its units are also volts. And what is the instrument which is used to measure potential?
Voltmeter.
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 For electric current,
Ammeter.
ammeter.
Ambit.
Formulas you remember better. I is equal to Q by T, and here V is equal to W by Q. Somewhere you write if you want. The next is what?
Ohm's law.
Okay, directly Ohm's law. Ohms. George Simon Ohm in the century of 18th, he was given a very famous law which is related to V and I. What is V? Potential. And what is I? I represents what beta? V represents potential.
Electric
I
current.
represents what? Current. Okay. What is the statement? George Simon Ohm. He's a George Simon Ohm. So it states that at a constant temperature, the amount of current flowing through a conductor is directly proportional to the potential difference across its ends. Mathematically, I proportional to V, V is equal to I into R, where R is called constant, and that constant he named it as
Resistance.
resistance. Can you repeat the statement of Ohm? Anyone? Whether Amulya or Lakshita?
It states that at constant physical conditions like
Conditions.
temperature are kept constant, then the amount of the current flowing through the conductor is directly proportional to the potential difference.
Across its ends.
And
I proportional to V and V is equal to IR.
IR.
According to this, the one which obeys the Ohm's law are called ohmic conductors, which does not obey they are called
Non-ohmic
non-ohmic
conductors.
conductors. And even they give graphs also. See the graphs between V and I. Most important beta. Ohmic conductors, as they obey Ohm's law, we will get a straight line. And non-ohmic conductors, as they does not obey the Ohm's law, they'll get a curved line. Examples for ohmic conductors means all metals: copper, zinc, silver, gold, iron, platinum. Whatever the metals are there, all metals will obey the Ohm's law. And non-ohmic conductors are nothing but semiconductors. Example: silicon, germanium. They'll ask you in question as what are ohmic conductors and what are non-ohmic conductors? Explain any two differences between them. Ohmic conductors are the conductors which obeys the Ohm's law. When we plot a graph between V and I, we'll get a straight line. And non-ohmic conductors are
which does
conductors which
not
does
obey.
not obey Ohm's law.
Home.
Examples: semiconductors, silicon and germanium. LED. Your LEDs also comes under non-ohmic beta because LEDs are made up of with semiconductors. And now let me know what is resistance and what is resistivity.
Resistivity.
Do you think they both are same or different? What's your idea, basic idea?
Different.
Different. Let me learn what is resistance first. So he was given a very technical word called hindrance, means opposition. I simply call the opposition of law of current. In any conductor, if there is an opposition, so that causes resistance. Am I right, children? Suppose I am telling anything, you are opposing it. I said complete homework by today. You said no, no, no. So you are resisting me or not? You are resisting
Yes.
my instruction. Similarly, when your parents are telling anything, do this work, immediately you say no, no, I don't want to do it. So you are resisting there also. You are opposing. So here, opposing the flow of electrons in a conductor causes resistance. And from Ohm's law, what is the formula of R? V by
I.
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 Because V is equal to IR, then R is equal to V by I. What is V? Volt, unit I'm telling. And for current, ampere. Volt per ampere is also called ohm. George Simon Ohm. Scientist name only were given. And the reciprocal of resistance is called conductance.
Conductance.
That is not R beta of reciprocal OF of. Reciprocal of resistance is called conductance. Resistance opposite word is conductance beta. Up to here, is it clear?
Yes,
Okay,
sir.
question.
Yes, sir.
Resistance is a property of a conductor dash to the flow of current.
Opposition.
Opposition. Formula for R,
V by I.
V by I.
V by I. The SI unit of resistance,
Volt per ampere.
Volt per
volt
ampere.
per ampere, is also called
Ohm.
ohm. Reciprocal of resistance is called
Conductance.
Conductor.
Conductance.
conductance. Beta. Very good, very good. Now, what are the factors which are affecting? These are the most important beta. Resistance is directly proportional to the length, and resistance of a wire is inversely proportional to the area of cross section, and together are proportional to L by A. When I remove that proportionality, here my proportionality constant is specific resistance. That's what in future we'll learn resistivity also. So two factors. One is length, one is area. For length, it is directly proportional. For area, it is inversely proportional. And together the formula is R is equal to rho L by A. Here rho is called specific resistance.
Resistance.
Can anybody repeat? What are the factors which affect the resistance? Anyone?
Sir,
Yeah,
R is
Pulkit.
inversely proportional to length
Hmm.
and R is
Directly proportional to length.
directly proportional to length and inversely proportional to area of cross section.
Very good. Together, R is equal to, what is the formula? R is equal to rho
Rho
L by A.
A.
What is rho is called beta?
Specific
Specific
conductor.
resistance.
Resistance of the
Specific.
conductor.
Uh, Specific resistance is a resistance of a conductor in unit area per unit length beta, or unit area of cross section. And remember, specific resistance is also known as resistivity. It depends on material of the conductor and SI unit is, this is most important. What is the SI unit of specific resistance beta? Ohm,
Ohm meter.
Meter.
Ohm meter.
and it is proportional to the temperature. Not only this one beta, resistance also depends on temperature. Resistance also depends on nature of material. So these are the some resistivity values. So for instance, are you watching now? what is the resistivity of steel beta? Steel.
7.2 into 10 to the power of minus 7.
10
Very good
minus
beta. 7.2 into 10 to the power of minus 7
7.
ohm meter. That's a unit. And what is the resistivity of a coal?
3.5 into 10 to the
5
power
into
of
10 power
minus
minus
5.
5 ohm meters.
3.5 into 10 power minus 5. Is resistivity is more or less 3.5 10 power minus 5?
Less.
More.
4.
Less value, but compared to these metals, it is more. Compared to the metals, it is more. The highest resistivity is for which material? In the given table, the highest resistivity is for which metal? Which metal, which material? Which material is having high resistivity, Nana? Are you not seeing? Which is having uh, platinum? No. Platinum is also in the 10 to the power of minus only, no.
Yes.
10
Rubber.
to the power of plus value must be there and it must be highest. Which material it
Rubber.
is?
Rubber.
Yeah.
Rubber.
Rubber also 10 power 13 only. Are you not able to see quartz?
Sulfur.
Quartz?
Sulfur.
Below that sulfur quartz is there whose value is 7.5 into 10 raised to 17. So which is having more in the table?
Quartz.
Quartz. Quartz is nothing but which is used for like one kind of diamond type of material only. So types of resistances. In the left picture, you are seeing the fixed resistances. In the right picture, you are seeing the variable resistances. So both are used in laboratory purpose. When we are using, you require only the specific value. You will take fixed resistances. When you are using, when you want to vary the value by the doing the experiment, so that time they use variable resistors. Variable resistors is also known as rheostat. Understand? Okay. Generally, an electric circuit consisting of. Do you know what I mean by circuit first? Before I'm going to talk about, do you know what is your idea about circuit beta? What is your idea about circuit? Circuit consisting of what? Do we require a battery in a
Yes.
circuit? Yes. So I
Yes.
can say you any circuit will require power source, power consumer, and power connectors. Let it be. I'll just show you one more for you. This is what previously which we made for people. Are you able to see screen better?
Yes, sir.
Yes. Sir.
Even more detail. This is observe the pictures and comment better. Which side the bulb will glow? It's a ceramic. Ceramic means the wash basin one, or you can say saucer type material. And this side is a conductor, right side. And the left one will glow, or the right one will glow.
Right.
Right.
Right, because ceramic is a bad conductor. So that's what they're showing. You see, in ceramic, what happened? Electricity is blocked because it is insulator. Whereas the right side one is a conductor, so the bulb will glow. Not all the materials will conduct electricity. So this is how an electricity flows from positive to negative. And see here, when a wire is connected, is the bulb is glowing in picture? Say yes or no. Is the bulb is glowing better or not glowing? Not glowing because
No.
I was connected another small wire in middle and electricity is flowing through that one. So this kind of circuits are called short circuits. This kind of circuits are called what? Short circuit. Due to short circuits, more voltage will pass and appliances will damage. So this is a formula of I. I is equal to Q by T. So these are the points. Current is a scalar quantity. Yeah. A circuit consisting of what better? A battery, a bulb, and the wires. Observe the circuit and comment better. This like this I explained for your friends. What is the difference between three pictures?
First one, battery and bulb is there, but wire is not connected to bulb.
Very good.
In second picture, the battery is
Not
not.
there, so it will not be.
Hmm.
And next
In third
is
picture, battery
The
is
wire
connected,
and battery
wire
is
is also
connected.
connected.
So it
Bulb
is
is flowing.
Okay. So among the all, which one is called open circuit? First, second, third. Open circuit.
so first one,
First,
First one as well as
second one,
second one. Both are called open circuits. And third one is called
closed
closed
circuit.
circuit.
closed circuit. Good. What are this? You see in the picture,
Am-
A is there. That's an ammeter,
Ammeter.
which is used to measure electric current.
Current.
electric current.
Not only ammeter, galvanometer also used to find electric current better, but smaller currents. Not only ammeter, galvanometer is also used to measure current, smaller currents. So this is the formula for what? I. So whichever you want to make subject, that one you block, you'll get it like a magic triangle. So if you block I, Q by T. If you block Q, I into T. If you block T, Q by I.
I.
So this is what the potential difference, how it comes. If you exercise with it, it's foundation material, no? So it was consisting of total. This is what Ohm's law. This is what the reading, the values you see, the corresponding voltages and corresponding currents. I was tabulated them, and they plot a graph. When see a graph, it is looking like a straight line. So what are the factors affecting resistance? Length, area, temperature,
A.
and material. And specific resistance, what are its units? The reciprocal of resistivity is called conductivity. And this is again, and this is the most important color coding which comes now. And after that, we have combination of
Combinations of resistors.
resistors. So that time will come here. But now, do you understand circuit consisting of what, beta?
A battery,
Battery.
wire,
Hmm. A
wire,
battery, yeah,
wire, and a
wire,
bulb.
bulb
Bulb.
means power source, power consumer, and power connector. Power source, power consumer, and power
Power
connectors.
connector.
Connectors are nothing but wires. So that is what they are showing. If it is completely closed, everywhere it is there is a flow, then we call closed circuit. If it is not closed, we can call it as open circuit. So what are these better? Circuit symbols. So just see, electric cell can be denoted like that. You see it now. Again, I'll ask you in practice paper. I'll draw. You should say. If you said okay, then we'll go ahead to the practice paper where I can ask a symbol. I'll draw. Immediately you have to say. Done, beta?
So 1 minute.
Very simple. You can do it. It's very easy to know these symbols, beta. Yeah. This is a symbol of
Battery.
Cell.
battery. Battery or cell. Correct. Both are correct, beta. This is what is it?
Bulb.
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 This is, if you write like S letter, it is called
Fuse.
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 fuse. And this is resistance.
Resistance.
This is
Resistance.
called what?
Resistance.
And for same resistance, if they show with an arrow mark, call it as RH. What is RH, beta? It is a rheostat. What you can call? Shall I write fully? Rheostat means what? We can here vary the resistance. But in case of first fixed resistance symbol, this is the rheostat variable resistance symbol. Till now is it clear?
Yes, sir.
Yes, sir.
Yeah, if two wires are like this and there will be a point or a point shows like here, they are connected. And two wires are like this and there is a mark like this, those two wires are not connected.
Connected.
So connected wires, not connected wires. And in a circle, if this denoted with A and a circle is
Ammeter.
denoted with V,
Ammeter.
Ammeter.
Meter.
ammeter, V for
Voltmeter.
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 If I keep G,
Galvanometer.
galvanometer. So these are the some specified circuit symbols. Is that clear, children?
Yes, sir.
Good, very good. Listen concentrately. The next we have, so which are the measuring devices? Ammeter. What is the use of ammeter? To measure. Ammeter is used for what? Electric current.
Electric.
Electric current.
Hmm, electric current. Voltmeter. Voltmeter, by name itself, it is telling measures potential difference. What it measures?
Potential.
Potential.
Hmm. But see here, ammeter always connected in series, beta. First line you see, ammeter is always connected in series, whereas voltmeter is always connected in
Parallel.
parallel. So I think now we need to learn the combination of resistances. So resistance can be combined together to get series combination as well as.
Parallel combination.
Hmm. So what happens when two resistors are joined in series? I think we need to come to our slide. Just a minute, guys. Yeah. Are you able to see the screen better?
Yes, sir.
How many resistors are there? Three.
Three.
R1, R2, R3.
R2.
So the flow of current is same everywhere. Here is I, here also I, here also I. Then what is dividing better? As current is remaining same, what is dividing here? You see here, I'll underline. What is divided here?
Potential.
Voltage. Then total potential difference can be taken as V is equal to beta total voltage V1 plus V1 plus V2 plus V3.
V3.
But you know from Ohm's law beta, Ohm's law V is equal to I into
R.
R. V1. Here I is there, here R1 is there. So I R1 plus V2 I
R2.
plus finally I
R3.
R3. What is common and cancel? I is taken common and cancel. Remain what? R is equal to
R1 plus R2 plus R3.
super. R1 plus R2 plus R3. So what did you understand? When three resistors are joined in series, the effective resistance, net resistance, total resistance, equivalent resistance, all are same beta. You should add them. You should
Add
add them.
them.
Where in case in parallel, whatever the current is flowing here, earlier what is divided beta? Potential is divided. But now what will be divided? I am writing here C and say I1, I2, I3. What is divided beta here? Current will be
Current.
divided. Then how to start? Total current. I is equal to
I1 plus I2 plus I3.
super beta. I1 plus I2 plus I3. From Ohm's law, what is I? V by R is equal to V by R1
R1 V plus
plus
V by R2
2 plus
plus
V.
V by R3.
so V is common then 1 by R is equal to.
1 by R1 plus 1
plus
by
1 by
R2
R2
plus
plus 1 by
1 by
R3.
R3.
So in case of parallel, you should add reciprocals. In case of series, you directly add them. But in case of parallel, you take the reciprocals addition. And remember, so do you know this word beta PVC? PVC pipes. Have you listened beta?
Yes, sir.
Yes, sir.
Yes, no? The code is in parallel. What P represents?
Parallel
V
Parallel.
for
voltage
Voltage.
C
con-
for constant.
constant.
In parallel, voltage constant. If you remember this, it's very easy. So in parallel, voltage is constant. In series, current is constant. Got it better? As we go across these types of cells, whether they're given or not. Okay, not given. Here only we should study. Fine. Now I'll give one example. These resistor values I'll give you. Tell me if R1 is 10 ohms and R2 is 20, R3 is 30. When these three are connected in series, what is effective resistance? If R1 is 10 ohms, R2 is 20, and R3 is 30, what is effective resistance and how? I want little explanation also. Give answer and explain or justify your answer. Anybody? You're giving correct answer only.
R is equals to R1 plus R2 plus R3.
Very good.
Then
R
R
is
is
equal
equals
to, okay, I'll write it better. Just a minute. R is equal to R1 plus
to R2 plus
R2 plus R3 because as they're joined in series. Yeah.
R is equals to 10
Hmm.
plus 20 plus 30 is equals to 60.
60. What is the unit? Ohms. What is the
Ohm.
unit? Ohms. Let me take one example for parallel also. Parallel, if I take only two, instead of this three, if I take two, let me check whether you can do it or not. 6 ohms, 3 ohms. What is effective resistance? 6 ohms and 3 ohms.
3 by 6.
Yeah. 3 by 6. Let me check. 1 by R is equal to 1
1
by
by
6
R1
plus.
plus 1 by
1 by 3.
3.
Hmm. Down LCM 18. I multiply better. So 3 plus 6.
9.
So 1 by R is equal to beta 9 by 18. Because we don't want 1 by R, we want R. So R is equal to
2.
2. So what is the answer? 2 ohms. When 6 ohm and 3 ohm is connected in parallel, the effective resistance is 2 ohm. Children, remember when you are taking two resistors, it's very easy to take product by sum. Na? R1 R2 by R1 plus R2 is a very quick to use. I wanted to make train for you that. That's what one more example. What do you take? R1 R2 by? You multiply the
R1
resistance,
plus
you add
R.
the resistance. 6, 4. 6 ohms and 4 ohms. What is the answer? Effective resistance, please. Directly, I want to answer.
2.4.
2.4. Very good. How did you get that? 6 into 4 by
6
6
plus 4.
plus 4.
6 plus 4. 6 4s are
20, 20,
20.
24. 6
28.
plus 4,
10.
10. So 24 by 10, it is 2.4. So in this way, we can calculate what? The effective resistance when they're joined in parallel and as well as
C.
series. So what did you observe? In case of when resistors are joined in series, resistance will increase. But the same resistors are joined in parallel, resistance will decrease. So that's what in series how they derived, and in parallel how they derived. So what is the major differences between series and parallel? I expect children please take screenshot of this one, which will be very useful for you in future. Took screenshot?
Yes,
Yes,
sir.
sir.
Very good, nice. That's it, beta. That's we call part one. Do you understand anything?
Yes, sir.
Yes, sir.
Yeah.
Yes,
What did you understand, beta? What did you understand?
Sir, about electric circuit, open circuit, closed circuit,
Hmm.
and
Electric
resist
current. Yeah.
electric current, Ohm's law,
Hmm. Ohmic conductors, non-ohmic conductors, resistance, resistivity, conductance, conductivity, and loss of resistance called factors affecting resistance. Most important, R is equal to rho L by A. And finally, series combination of resistors and as well as
Parallel combinations.
parallel. In the next part of the thing, we study about heating effects of